Yeah, students, today we are going to discuss the first lecture on probability. Uh, this is offered in the second year, second semester. The subject is probability and statistics. So the first unit of the probability and statistics is probability. Here, the syllabus of the first unit is basic concepts of the probability, and then what are the axioms of the probability, addition theorem in the probability, and then conditional probability, multiplication theorem, Bayes theorem, and about what is random variable, and the types of random variables we'll discuss, that is discrete and the continuous random variables. And after that, we'll discuss about probability mass function and the probability density function, and then followed by the expectation and the variance. So this is the syllabus in the first unit of the probability. So here we are going to discuss about the first lecture on this probability. So in this lecture, first we'll learn about what is meant by a random experiment, and then sample space, and then what is event and the types of events, and the definition of the probability, and finally we'll discuss about the axioms of the probability. Yeah, here the probability is a subject that is dealing with the uncertainty, which enables us to quantify in terms of the mathematics. So that is the reason the probability is also called as a mathematical measure of uncertainty. We know that what is meant by an experiment, an operation which can produce some well-defined outcome, then it is called as an experiment. There are the two kinds of experiments. One is called deterministic experiment, and the second one is called probabilistic experiment or random experiment, or the other name is non-deterministic experiment. So whenever the result of an experiment is unique, even after performing that experiment many number of times, the result is always same. Then such experiments are called deterministic experiments. Yeah, see here, when we perform an experiment in the science and engineering and repeat the same under the identical conditions, we get the same result every time. So this type of experiments are called deterministic experiments. If you consider any scientific experiment, that is, it may be a physics experiment or a chemistry experiment or any engineering experiment, if you perform that experiment under the identical conditions, the result will be same. So this type of experiments are called deterministic experiments. Now, non-deterministic experiment is also called as a random experiment. When an experiment is repeated under the identical conditions and the result varies from the time to time, from experiment to experiment, such experiments are called non-deterministic experiment or random experiment. See the examples of the random experiment: tossing a coin. When you toss a coin, the result may be heads or tails. Supposedly the result is heads on the first time, and if you toss the coin again, the second time the result may not be heads. So we can consider this as a random experiment. Similarly, throwing a die. Yeah, here we consider the die nothing but it is an unbiased. That is, all the 6 faces have an equal chance for its occurrence. Yeah, here the faces are given by the numbers, say 1, 2, 3, 4, 5, and 6. And when a die, unbiased die, is thrown, say the first time is the result is 2. That is the face 2 it has shown. Again, if you throw the die, it may not be 2. It may be 3 or 4 or 5 or 6, any other. So this is also an example of the random experiment. And the third one is drawing a card from a well shuffled pack of cards. Yeah, we know that there are the 52 cards. Suppose in the first time, if after drawing the card, say the number is 9, the next time the same number card may not become. So drawing a card is an experiment, and it is also called as a random experiment. Now, the probability is a subject that deals with this type of experiments. So Probability is a subject that deals with a random experiment or a non-deterministic experiment. That is the other name we used. Now, the sample space. So, sample space is a set of all possible outcomes of the experiment. For example, a coin is tossed. Then, the possible outcomes are head or tail. So, these are only the two possible outcomes of the random experiment when a coin is tossed. Usually, the sample space is a set which is denoted by the letter capital S. Now, we know that in the set theory at the high school level, always the sets are represented by the capital letters and the elements are represented by the small letters. So usually here in the probability, we use the sample space by the capital letter S. Now, each element of the sample space is called as a sample point. That is, if you consider an example as tossing a fair coin, there are the two possible outcomes. One is head and other is tail. And for our convenience, instead of writing the head, so we represent the result as capital H. And for tail, we represent that by capital T. Therefore, the sample space S is equal to a set consisting the elements H, T. And the number of elements in the sample space is equal to 2. N of S is equal to 2. Now, the second random experiment we are considering is throwing an unbiased die. Yeah, there are 6 possible outcomes. We represent the faces by the numbers 1, 2, 3, 4, 5, 6. These are the digits we used to represent for the faces of the die. And therefore, the sample space S is the consisting the elements 1, 2, 3, 4, 5, 6. So the number of elements present in the sample space are 6. Here each element is a sample point. And now the number of the elements in the sample space, that is N of S, is equal to 6. Yeah, for example, if you consider the random experiment as tossing the two coins, then what will be the sample space? So, to write the sample space set, here the two coins are tossed and each coin has 2 outcomes. So, 2 into 2, that is equal to 4. 4 possible outcomes are there for this random experiment. Yeah, here occurrence of head and occurrence of tail. When the coin is tossed, it may be heads or tails, and 50% is chance for the both. And since the 2 coins are tossed, so therefore the possible outcomes are HH, that represents both the coin shows heads, HT, the first coin shows head and second coin shows tail, and here the first one shows tails and the second one shows heads, or the last possible outcome is both the coin shows tails. So if you want to give the number, like that is, this is the outcome which shows both the tails, so therefore the number of hits occurred on this outcome are 0. And here 1 head occurs and 1 head occurs, and this is the first one is the 2 heads occurs. Therefore, the sample space is consisting of these 4 elements. So therefore, the sample space S is equal to HH, HT, TH, TG. And now the number of elements in the sample space is equal to 2 square, that is equal to 2 into 2, which is equal to 4. Similarly, suppose 3 coins are tossed, then what will be the sample space? So each coin has the 2 possible outcomes. One is head and other is tail. And like that, the coin is tossed for the 3 times, or the 3 coins are tossed. Then the sample space is consisting of 2 power 3 elements. That is 2 cube, which is equal to 8. The number of elements in the sample space are 8. Similarly, 10 coins are tossed, or a coin is tossed for the 10 times. Then the number of elements in the sample space are 2 power 10. Now the next example, when the two dice are thrown, then what will be the sample space? Here, when a die is thrown, there are the 6 favorable outcomes possible.